Okay, everyone, this is my channel. I'm Peter. So today we just keep talking about the compulsory physics in the high school. So today's topic we're talking about the interaction. So first of all, that the interaction actually in our nature, which means we can we can just talking about this one about the actions. So I take something for example. uh, if here's there is a if there is a bolt and someone just scratch it. So if you scratch it, what will you just squeeze the elastic bolt, so the ball will be happen. What happened? Actually, the balls will be become flat, right? So when the balls become flat, so the we means that this art will maybe you will see use the force, but actually we can use a kind a word that actions. So and now we can do to another kind of things that we take another example for this one. If here's a ball, also a ball, and this is another ball, then the both balls are on the ground, and this one will be we label is one, and here is number two. So when the number one balls and the one balls and the two balls will start to scratch each others, so that the number two will be have the first one, and number one have the first two, right? So we will cause this will be the actually that this is because these two balls actually have interaction between the two balls, right? However, that actually in the physics words we try to use we will use the force this one in the microscopy. However, actually when we are in the microscopy, or we call an atomic scales, we will use the words interaction to represent the force. Okay, so I think this we got to remove it. So the first one we're talking about the interaction. Actually, we will use these words in the atomic scale or microscopic. Okay, so now that if we're talking about something we in the microscopy, we means that we will often use the first one. So we will use the first to replace all of it. And also the first we can use with when we can see something with your naked eyes, and actually this is just we can use just use force, that will be great. Okay, so the first we use the microscopy. So this will be great. Okay, so first that we want to when we have you already know the interaction, that there's some difference between the interaction and the force. So today's we have to introduce the force interaction in these sections. Actually in nature there's a force interaction to have affect our words. So the first of all we try to want to introduce that will be the gravitational force, or maybe the gravitational interaction. So the first one is that if you want to calculate the magnitude of the gravitational interactions, we will use a formula that I think everyone will be very very familiar with it. But however, I won't just give you the formulas. We were talking about this for examples. Here will be the max 1, and this is the max 2. So there is the okay, you can imagine that this is just two balls or two field, and this field will have the max, and also that the max will be here, and here will be have the actually the distance between the center of max and we call this distance will be the r. So finally, if you want to calculate the magnitudes of these ones, you will get the max 1, the products of the max 1 and max 2 over the r squared, right? So if you want to, we found out that the longer the distance and the smaller than the magnitudes of the force or the action. So we finally will get this formula will be the Fg is equal to the 1 m1 m2 over the r squared. So also that if you want to get the equal, so you just have insert and constant we call the g. And here the g is actually just we call the gravitational constant. And these constants have the values about that the 6.67 times 10^11. Okay, so this is the magnitude of the force. Also that if we're talking about the gravitational interaction, this is great. Also, and now that if we want to, so if we want to talking about the next, that will be the electromagnetic force. We're talking about another interaction. Will be electromagnetic interaction. And next interaction actually including two parts. The first of all will be including the electric force. And the magnetic force. Okay, so when we're talking about the electric force, actually there is another a man who called the Coulomb, and the Coulomb proposed laws to figure out the magnitude of the series. We call the Coulomb laws, and the Coulomb we can get that is very similar to the gravitational force, right? We get the Coulomb force will be equal to the k. We use the k to replace the gravitational constant, and we can write q1, q2 over the r squared. And here that here the q's, which means that is the electricities. We call it charge. And charge have the electricity, and also charge have the positives and the negatives. So it's up to which one you want to focus on it. Okay, so this is the Coulomb laws. And when we finish out talking to the two Coulomb laws, actually that there is another we call the magnetic force. And the magnetic force will use the M. However, that we didn't talking in the high school about the K, M1, M2 over R squared 2. So actually this is all this is not in our syllabus, so we didn't told it, but I just want to tell you that both of these formula have the very similar symmetries about these ones. Okay, so all this and this, including the Coulomb laws and the magnetic force, actually is only for the static charge. However, if you want to discuss together, actually that you want to discuss together, you got to have to we got to talking about the integration of the electromagnetism. So now today we didn't tell you how to figure out it. So the next we were talking about the we replace to talking about the magnetic force, but I got to tell you another web to help you to visualize the magnetic force or the electric force, how to affect the space, and we use a kind of lines to help us to visualize. So here is some. So here, this is a magnet, and we know that magnet have some interesting properties, right? The magnet has the M force and the source force. And the M force and the source force actually that he had some the M and some will be, you can just imagine that there is some there's a force the force affecting in the space, and finally that this space will be, you will back to the magnet just like this one. Okay, so that's great. And when we start from the N and N in the S, so actually that we can get some important properties in this point. So the first will be the magnet must have M source and M ports and S source ports. Okay, so they are together. We cannot just, the others cannot exact the monopoles. It's not exact. And also that the lines will not cross it. Okay, so they will not intercross each others. Okay, and also that there is including that the from M, they were pointing outwards from M to X. So this is outwards, and also you will from the S point outward to the end. This is the inside the magnet. Okay, so all these things are really important. So when the lines will affect the space, which means that is, but these lines cannot just stand for the magnitudes of the magnetic force. Okay, so these are important topics to introduce the way. And in the sense, you can use these ideas in the electrics. So electric have the electric lines and also have the gravitation lines in our topics. So this is really great. Okay, so the next we're talking about that. When we finish all this one, we're talking about the nucleon. Something will happen. We call the strong interaction. So, and about the 1930s, there is a professor in Japan, Yugawa, and he proposed ideas that there is some the mason which means the pipes. The pi mason will be have some the pi decays will be a prediction, and however that you finally find out there is something there's another interaction between this movement. I'll take something for examples. If this is the nucleus, and there is some proton in the nucleus. Okay, so the nucleus, and we know that the nucleus there's a force of the protons in that years. So we know the proton actually is a positive. So if you know that there's a two particle have positive charge, so they will repel together. They will repair it out, and also that will cause the they will induce the force. Over here, they will induce the force. Okay, and also that the more the when the force is confined in the nucleus, and there will be have the larger Coulomb force will be increasing. Okay, however that the nucleus there's if there's lots of proton in here, and nucleus must be the force must of the electricity must be very very large. However, there is maybe something can help to attract each particle together. So maybe you will think that I know that if want to attract each other, maybe we can use the gravitational force, but this is not a great idea because the gravitational gravitational force actually is smaller than it's very small than the electric force. So someone thinks that maybe there is some another interaction exists in the nucleus. We call this really strong, so we just call it the strong interaction. So I think that's cool, right? So here this is a strong interaction over here. So the strong interactions actually larger than the electromagnetic force and also larger than the gravitational force. So this something will happening, and we also find that if the strong interaction have these properties. So here we told you that the first of all that is the positive charge, and the positive will be in the same distance. There will be have the same strong force, and also the neutron and the proton will have the same magnitude, and also the neutron and neutron in the same distance will be have the in the same distance have the same force magnitude of force. Okay, so this is we can just ignore the electricity of the negative or positive. This is not important for us in the strong interaction. Okay, so here we want to introduce another interaction we call the weak interaction. So the weak interaction actually we can think about this is just we're talking about the decays. The radiation will cause the decays. So the decays will cause from the weak interactions. So they talk about that a man that proposed that the neutron, if the neutron start to decay, and there will be there's some products in the reaction we call the protons, and the electrons, and also the neutrinos. So this is what we know in these topics. And here's if you find out the products of the reaction have the electrons. We call this electron will be the this reaction will be the beta degree. Okay, so this is the beta decay. Okay, so finally let the positive electron and the antineutrinos. And the antineutrino actually very smaller. The neutrino actually very smaller. So that and with the less mass, and he cannot interact with the others interaction easier. So it's hard to observe it. And also that some people or some scientists think that maybe the neutrino actually is really important, have the important roles in our universe, but these all things we just cannot testify. Okay. So in the high school physics, if we're talking about a weak interaction, we can always from the fusion. So the fusion will be happened the weak interactions, and also the beta degrees. So you just memorize it. You just memorize this one, and you can I think that you can get a great good grades in the exams. Okay, so now that I have all of you to make a tables to help you to understand the difference between these force interaction force. So the first of all that we're talking about the G. Okay, so the G will be gravitational force, and the E will be electrostat or call it electromagnetic force, and also the strong interaction and the weak interactions. So all these force interaction actually we can talking about that. The first of the is the effective space. So the first of all, we want to talking about the space which the interaction force can be affected. So the first that G gravitational space is everywhere, and also the electromagnetic force as everywhere. However, the strong and the weak interaction in just can happen, or we tell you occur in the nucleus. Okay. And finally, we're talking about the force, the magnitude. The strong will be the number one, and the electromagnetic interaction is number two. And maybe you will think the weak interaction is the last one, right? However, the weak interaction is the number three, and the final will be the gravitational force, number four. Okay, so this will cause the magnitude. Okay, so this is great. So and today we just finished our talking about the interaction and try to introduce all these things. The next section we will start to talking about the kinematics and the matter when the matter start to moving, so how to describe the motion. Okay, so see you next time. This is Peters. So see you next section.